Hello and welcome to another tutorial. So this time around, going to be taking a look at the interaction side of the behaviors package. So the interaction system is at this point fairly old, and it is the architecture of it kind of runs into a number of issues there with it. So I want to overhaul things, make it a bit easier, a bit more flexible to work with, make it so that getting new interactions set up is a lot quicker and simpler. I also want to, with this, add in a bit more decoupling. So at the moment, everything is very tightly coupled. So it means everything is needing often direct references to stuff. So I want to try and eliminate as much of that as possible. Now, there's quite a bit in terms of changes that we need to do for this. So in terms of how I approach this, for one thing, this is going to be split up across at least 2, might end up being 3 tutorials. But what I'm going to do is initially, I'm not going to do any removal of the old system. Initially, what I'm going to do is focus on getting the new system implemented, but not have anything using it first. That's going to be the initial focus. And then we'll take a look at the side of updating the behaviors, because there is quite a lot that we need to do for that, but the end result is going to be that we have debugger support for our interactions, that we have also support for making it, easy to work with them, to be able to set up multiple points that you're interacting from, to tie those interactions into particular points or particular look targets. So that's sort of the focus that we're going to be looking at with this. Now, in the description below, you'll actually find 3 separate links. The first is the link to the code as it is at the current stage where I'm starting this tutorial. The second link will be a link to the code at the end of this tutorial. And the final link will be to the completed AI package. Now, depending upon when you're accessing that package versus when this tutorial was recorded, there may have been further additions to that package and further things that have changed. That's just something to be aware of because I'm continuing to add to and update that package. But you do have the links there to the different sort of snapshots in version control. So let's dive on in. So as I mentioned, the focus with this is going to be on setting up things so that we have our new interaction system first. So I'm going to just hide away a lot of the stuff here because we're not going to be removing anything. What we're going to be doing is we're going to be adding and setting up things. So that's sort of the focus there with that. So, okay, what I'm going to do is create a bunch of folders to begin with. So this is going to sit in the character core. So whereas the previous one was in the framework essentials, and as I've mentioned before, I'm trying to sort of phase out that framework essentials side of things. So I'm going to have a interactions folder. Now we're going to have quite a few things under that. So we're going to have a whole bunch of interfaces that we define. We're going to have some common stuff for our interactables. We'll have another one for our interactions. And we'll also just have some essentially miscellaneous common stuff. So we'll have a common folder. So that's good. That gives us our general sort of structure that we're going for with this. So the interfaces are what I'm going to set up first. So we're going to have a few different ones here. So we're going to have our IInteractable. So anything that can be interacted with, like the TV, for example, that will be an IInteractable. We're going to create one for our registry of those interactables, because at the moment everything has to use with the smart objects, it's that smart object manager that we can see in the scene. With this, by having an interface, then I can have it discoverable through the service locator, which means if you want to set up using a completely different base class for the registry, then you can do that. So that's the whole reason for going through interfaces for all of this. Forces very clean sort of structure and also makes certain that achieves sort of the goal of being able to have things be decoupled and very sort of constrained interactions between them. So we have our IInteraction interface. Interactions will also be able to support a look target. So we're going to have an interaction look target. We will also, because an interaction has a particular location it can occur at, so there will be an IInteraction, and this will be a interaction point. So that's where the actual interaction occurs. And then the other thing is who is performing the action. So in the smart objects, we manage this just using a game object, but I want to be able to get a little bit more information out of it. So I'm going to actually have an IInteractionPerformer as an interface. That will make it possible to have some key information anything interacting with stuff has to provide. And also, again, I'm trying to reduce dependencies on things like game objects and mono behaviors where I can. So the final one that I need is, again, that process for selecting an interaction. So at the moment, we just have a randomized selection. But again, you might want to be able to easily override that. So I'm going to have an IInteractionSelector interface. So, okay, a lot of interfaces that we need to get set up. So we're going to get these all implemented first because these are pretty sort of key to what everything else is going to need to be doing. So I'm just going to modify all of these, because they'll get the same sort of standard modification of clearing out everything initially. I do wish by default there was actually just an option for creating an interface. I could set up my own template and my own helpers for it, and that is something that I might actually do and end up including in a future version of the project. I have added support before in other ones for custom classes, and it can be really handy. It saves a lot of time, because all of this is just editing boilerplate code, but otherwise wouldn't need to. So far, so good. Nearly done with the cleanup. Wait for this. Okay, so that's good. We've got those all cleaned out. So let's look at where we want to actually begin. So our Interactable is probably a good starting point. So there's a couple of things in terms of interfaces it's going to support. So it's going to support IDebuggable, because I want to be able to have these integrated with the game debugger. The other thing this is going to support, now this is one that is new. So I have set up within the Blackboard an interface iBlackboard Storable. The idea is for making it feasible for storing an interface within the Blackboard itself as one of parts of the content, because with me shifting more to using interfaces, there's more of a need for that. So I've just made it that as long as an interface implements this, which this doesn't actually have any functionality that it forces at this stage, that may change in future if I end up looking at saving and loading stuff in terms of the Blackboards. But for now, that interface just ensures that we have to have that set up. So, okay, couple of things I want to be able to make sure we have access to for every interactable. I want them to have access to the registry, because that's something that they might need to be periodically talking to that. I want to be able to keep track of our interactions that belong to this. So this is going to have a list, and this will be a list of our interactions. Similarly, there will be a list of look targets and a list of our interaction points. So those are going to be some common ones that every interactable needs to support. Now I'm going to also have just a generic query location. Now the idea behind this is if we are just doing something that is not interaction specific, I just want to get a rough suitable location, then query location is intended to be that. So for example, something might have multiple interaction points, but at the stage where I'm trying to figure out, well, should I try to move to this? I don't really care where the interaction point is. I care if it's free, but I don't really care exactly where it is. But I do need a location if I want to sort by distance, for example. So query location is what gets used in those cases. So it's purely for that sort of higher level operation. I need to keep track of what interactions are active. So this is the ones that are currently in progress that other things are actually working with it at the moment. So that's good. So a couple of other sort of helpful things that we're going to need. Well, a common thing is this interactable usable? So I want to be able to ask if it's usable. And I want to be able to ask if it's usable for a specific interaction. But I also want to allow that to be null. So if I provide a particular interaction that I'm asking, okay, can this interactable use this very specific interaction? If I provide a null, then I'm just saying, can it perform any interaction currently? So that's good. I want to be able to request an interaction point. So I'm going to have a request interaction point, and that doesn't need any parameters to it. I also want to be able to release an interaction point. So I'm going to have a release interaction point. Now with that, I have to actually provide the point. So the idea is if there is a particular location that we lock it. So that's good. Well, an interactable also needs to be able to be ticked. So we're going to provide delta time. So the idea is that an interactable, when it ticks, it will tick any of the interactions within it. Then, a couple of other little helper things. So one of the things that I want to be able to do is I want to be able to get out a set of matching interactions. Now, previously, the way that I've done stuff like this often has been to make that list accessible and be using that. What I'm actually going to do in this is this will give back an IInteraction list. And what it's going to be is it will filter interaction by predicate. So a predicate in this context is essentially a small snippet of code, typically a small snippet of code that will essentially answer true or false for whether something should be included or not. So I'm going to provide a system predicate, and this is going to have interaction as what it's working on. So this is our filter predicate. And then the other thing is those results, I might want to be able to sort them. So I'm going to have a IComparer, and what that IComparer is going to allow me to do is then have that also take in an interaction, and this is going to be in sort method. And we'll default that to null. So that will allow me to essentially provide a means to filter, so to reduce our set of what interactions are available, and sort that if that is desired. So we can pass back a sorted list of interactions. So it makes it a little bit more flexible for working with this. So that's good. The final thing that I want to set up is I'm going to have a began interaction. So I want to know when interactions have begun. So with this, I get the performer and I get the particular interaction. And I'm going to have for a few other cases as well. So I'm just going to copy and paste these because they have all the exact same parameters. So we'll have a ticked, we'll have a finished, and we'll have an abandoned. So it just lets us have hooks for essentially the full life cycle of an interaction of the different things that would happen to it. So that's good. Let's look at setting up our registry next. So this is going to be pretty similar. So this is a debuggable object rather than debuggable. And this is a locatable service. Now it doesn't need too many things. It's going to need a register interactable. So we have our interactable. Unsurprisingly, there'll also be an unregister. Good. And then this is going to have a similar sort of filter function. So the difference is this one runs on the interactable level. So this is going to be filter interactables by predicate. Now, it still will take in the same setup of having a predicate that takes in an IInteractable. So this is our filter predicate. And it will have same setup where we have a comparer, this time with an IInteractable. And this will be our sort, our in comparer. Like that. So that's good. I will, just for the sake of consistency, although I don't like bringing in system. So this one did automatically bring it in so it could access predicate. System is one I prefer not to bring in, especially with these things, because using random is quite likely and be very easy for it to drag it into a child class. So I'm going to not do that. Our IInteraction, so that has to be IDebuggable, and that is also Blackboard storable. So a couple of general sort of properties I want to enforce exist. Well, I want to have an is mutually exclusive. So this was something I didn't previously have. This just allows it that if we've got something that has multiple interactions, that they can't collide. So for example, the TV, you can only watch one program at a time. So I can set up multiple interactions and mark them as exclusive, mutually exclusive, and then that way it will allow them to sort of lock each other out. So it means if someone is watching a particular movie, then the other AIs in the scene have a choice of they can watch that movie, or I think will allow them to probably still turn off the TV. So that would be rude. So that's good. We want to have the maximum number of performers. So max simultaneous performers. That's good. I want to be able to know the current performer count. I think that's a useful thing to have direct access to. I want to keep track of what Interactable owns this. I'm going to also have a list of our look targets. So the reason being is that there might be certain look targets that are only relevant for particular interactions. Same for our interaction points. So we might not want every interaction to support every particular point. So that's good. We've got our look targets, we've got our interaction points. So we're going to give these, like we do for a bunch of ones, a bind function that allows them to be bound to their owner. They will have a tick function, like that. Similar to other ones, they'll have that is usable, but it doesn't need any parameters in this case. Then with the interactions, some general sort of workflow lifecycle stuff. One of the things is we need to be able to lock an interaction. So when we go to lock an interaction, we need to say what the performer is. And the result that we'll get out of this when we lock it is our interaction point. So if we successfully locked it for a particular performer, what we get back is, cool, you locked it, here's the point to perform your interaction at. So that's good. We will have a start interaction. I might call it begin interaction. Now, this one is a little bit more involved. So we do have our performer, but we want to allow a whole bunch of hooks, essentially, a bunch of hooks for other things being able to connect into this. So I'm going to have a system.action. So this will take in an IInteraction. And so this is our in on began fallback. So we just make sure we've got that as one. We will have one for when we tick, but this will be a func rather than an action because I want to be able to get something back. So this is going to take in our interaction. It's going to take in stuff like our time elapsed and the duration of an interaction. So both useful things for it to know. And it will return a bool indicating if we should keep going. So this is our onTick fallback function. And we're just defaulting all of these to null because these are ones that don't have to be provided and I don't want to force them. The final one that we potentially need a fair bit, this is actually the main one that we'll use, is our onCompleted fallback function. So that's really the main one that we'll ever actually use, but it's useful to have the other ones too in case we want to do different things. We will have a unlock interaction. takes in IInteractionPerformer. And then the final one we have is an abandon interaction that also takes in a performer. So that's good. So a lot of this is very sort of boilerplate, setting up all of these interfaces. It does take a bunch of time getting these things up and running, but it does make it that things will be a lot easier to work with in future. Now, IInteractionLookTarget, good news is, with the new point of interest system, we can just say that this has to implement IInteractableRegistry, and we're done. Straightforward. So nothing further that it needs. Our IInteractionPerformer, that needs to be a locatable service. And this does need a couple of built-in things. For one thing, I want to be able to access a display name that's going to be useful for debugging purposes. I want to also be able to retrieve its location. So interactor locate, or performer location, I'll call this. So that's good. That's all it needs. It doesn't have to do anything particularly much. Our interaction point, that needs to be Blackboard storable. But beyond that, what we largely are going to do is provide just a bunch of general interfaces. So I'll have point transform, have a direct helper for point position, and we'll also have one for the rotation. So that's good. So, okay, that's all the interaction point needs. Now, in terms of the interaction selector, this also needs to be locatable. So its job, it's going to need our interactable registry. Now, some of these ones, like the register in that, I potentially could remove them from needing to be in the interface, and that may be something I do in a later stage once I've got all of the bits fully tested and in a variety of scenarios and made sure that it's definitely not going to be needed. So it's going to have one for, do we have a minimum search range? So that is something I do want all of them to have to support. There will be a max search range as well. Then we'll need to define those. So min search range. I'm going to reorder this just because the only reason I did it out of order was so that the autocomplete would play nicer. Then the main function that this offers is a pick interaction function. And that needs to provide a performer. What it outputs is then going to be an interactable. So this is our outbound interactable. We also output the actual interaction. So our outbound interaction. And what I want to then do is I want to make sure that this has a way of doing some additional filtering. So I'm going to give this also a system predicate that it can apply to interactions. And this will be an additional filter. So that's good. So, okay, we have set up all of our interfaces. It's a lot of bits just to have those interfaces set up. But now that we've got those set up, we can start to actually build out some of the key things that we need. So, okay, let's start with some of the straightforward things. So our common ones here, we're going to have our interactable registry. So that's going to be one. We're going to have just a simple thing for our look target that we can add to stuff. So we'll have our interaction look target, and this will just be simple. And we'll also have a similar thing for our interaction point. So we'll have our interaction point oriented. Okay, let's get these implemented in terms of what they need to do. So I'm going to start with the interaction look target just because it's actually super simple. So this implements our, so it's still mono behavior, but it must implement our IInteractionLookTarget, which that gives us our getLocation function. So because these look targets, I want to do something more complicated with them, I wanted to make it so that it was a function. So what I'll then have is with this location, I'm going to just return transform position. So that looks good. That's all this needs to actually do. But I will add a component menu for character, interactions, look target, single or simple. Sorry, there we go. So that looks good. That's all it needs to do. For our single sort of oriented point here, it's also going to be pretty simple. So it's also mono behavior, but has interaction point implemented. This will be interaction point oriented. Just need to implement these. These are going to be straightforward. We're just going to use R transform. So we're not going to do anything complicated with this setup currently. This will use our transform position. And this one will be transform.rotation. So, okay, those are straightforward. Nothing too complicated there. Our interactable registry. We go here. Now this also needs to have our interface. So it is the IInteractable registry, but it's not going to just be a mono behavior. This is actually going to be mono behavior singleton, and with interactable registry provided there. So that's good. So now we have a bunch of things that have to be implemented. Oops. So debug display name, that's pretty easy. That's just going to be Interactables. We'll get to our filter function momentarily, because I'm going to set up a list here of IInteractable. And this is going to be our Interactables. And we'll just new it like that. So that's good. This will override. Oh, not that. Autocomplete going a little bit forward. So this will be a protected override of on awake. What I want to do first is register us with the service locator. So I register as a service, and I register myself as an interactable registry for this, and in a null context, so it's at the global level. Then I want to actually try to locate the game debugger. And if I manage to locate the game debugger, so we get our locatable service, and then all we do is our in service as game debugger, and we register us as a source. So that just hooks us into the system there, so that when the debugger is trying to get information from things, we'll appear there as an option similar to how the AIs appear. So we just register like that, so that's good. Now, our registering of an interactable, that will do first. So we can just do interactables and we add it. But what I want to check is, okay, if it already contains it, then I am going to throw a new system.invalid operation exception. And we are attempting to register an interactable multiple times. This means we have a helpful message for it. Unregister is also similarly straightforward. We remove that. Now with this, what I am also then going to do up here is our filter can be set up. Okay, so then for this, first thing I'm going to do is have our filtered list. So how we get that filtered list is we take our interactables and we then say find all, and we give it the predicate. Now, if that filtered list is null, or if it's empty, we return null. So we want to make sure we properly handle that. If we have a comparer, then I want to actually sort that filtered list using that comparer. And then I just return the filtered list. So pretty straightforward, not too much that we need to do with it. For the debuggable content here, we're just going to loop through every interactable in our interactables. And because they have to implement the interface for the debugger, we can actually go, hey, interactable, and we can tell it to gather debug data like that. So, okay, that's a few of the common things set up. You can see this is still remaining happy with us. So, okay, we've got common things set up, we've got our interfaces set up. So the next part that we want to implement is for our interactable. So I'm going to just set up a simple interactable script. So the idea behind it is this is going to be something that we could easily add on to anything. So it's just there is a standard sort of one that we can attach to things. I'm going to keep this open so I can steal that. So a simple interactable, set that up here, because most things will be able to just use that. So that's sort of part of the idea, is only setting up the things that we absolutely need. So this is going to be our IInteractable. And then with that, we've now got a whole bunch of things that we need to actually set up for this. So although it's going to put them in an order that I don't think is particularly great, I'm going to let it implement the default setup. Then with a lot of these actually change to be a get and a protected set. Do wish when, I guess, like I understand why when it's implementing the interfaces, things like of that, it just goes in alphabetical order because it's likely processing them in that way. But I do wish that it actually would have an option at least to be a way to respect the order that things are set up in. Because you go to the effort of setting things up in an order that you want, and then it goes and swaps it all to being alphabetical, which then means you lose the logical groupings that you might have set up, which is not great. So all of these can just be the same. The difference, well, the one difference is going to be our active interactions. I want to make sure that that is new from default because that's going to need to be directly worked with. So that's good. So far, so good. Our query location is actually going to, what I'm going to have here is have a temporary storage of a query location offset. And our query location will actually be transform.position plus the query location offset. So when I have some basic support, won't fully support it yet, but some basic support for being able to have the interactables be able to move around. So this is sort of a step towards being able to support that. So, okay, so far so good. I'm going to override, or I'm going to implement a wake method. And a couple of things this needs to do. So our debug display name, I'm going to directly populate that to the game object's name. And then the service locator, I'm going to attempt to do a locate on our registry. So it tries to locate our interactable registry. And all this is going to do is store like that. So that's good. That will just allow us to have the things sort of connected. Because it will have found it, I can register us with it. So we get that registration happening. What I will also do is, because we want to support unregistration, so virtual void and on destroy. So in the case of this, what I'm going to do is just have a helper for preparing to destroy, just because that will let us, sort out some general cleanup we might want to do. And then I'm going to, well, if our registry is valid, then we unregister. Now, in terms of the prepare to destroy, that I'm just going to set up down the end here as a protected virtual void like that. So I'll actually change this from being virtual, so I don't want things to mess with it. Same with awake, actually. So okay, that's good. We've got our prepare to destroy, and we've got our awake. So now we can get some of the other logic set up that we need to do. So, okay, we're going to set up our protected void start. Now, what I want to do in start is, firstly, populate things like our interactions, our look targets, and our interaction points. Good news is I can do that really, really easily. So I can say interactions, and that is a new list of interactions. But what I do is I say get components in children, and I can just say, okay, find that interface. Now, earlier versions of Unity didn't support the use of searching via interfaces like that, but that has been supported for quite a few versions now, and I have tested to verify that this works. So our look targets, we're going to do a similar process. Get components in children. So the advantage of all of this is going to mean that you don't need to manually link up these things. They're able to be just, you set up the actual game object for it, and then it's able to be found. Also means if you had multiple of that particular interface on something, then it's able to pick up each of those. So then we have our interaction points. So that's all set up. So, okay, that's good. We know that we have all of those populated. Then the first thing we're going to do is loop through all of those interactions. So interaction, go through all of those, and then we're going to bind that interaction to us. So that's just going to create the link, allow stuff to do any initial setup that it needs to do. I'm also going to figure out the sort of averaged interaction point. So we're going to have a vector3, and this is going to be our averaged interaction point. And what I'm going to do is default that to 0. Then we loop through, but we're looping through, in this case, point in interaction points. And what we do is just our averaged interaction point, we're going to add to that our interaction point, and we get the position, but we subtract from that our transform.position. So this is going to be how we figure out our offset. So then what we would do is our query location offset. Well, if interaction points, we actually have a valid number of them, then we use average interaction point divided by however many we have. Otherwise, our offset is actually just 0. So that's good. So we're able to figure out where that particular offset is. Then I'm going to have another little helper function here, just for if there is any sort of custom initialization that ones want to do. So I'll have a virtual initialize. We'll put it just above it, just because it makes sense to have the creation before the destruction side of things. So, okay, that's good. We've got our setup logic. Now, I am going to reorder a bunch of these things here because this ordering is not what I would want it to be. So I'm going to bring our debug data gathering and everything up here. And our usability checking, all of that logic, I want to bring that up here. Now for gathering the debug data, we can populate that straight away. So our debugger, we add a section header with our debug display name. We're going to push the indent. We make sure at the end we do a pop of that. And then all we do is we loop over all of our interactions and we run the debug data gathering for those. So that's good. Gathering of the debug data, nice and straightforward. Is usable is one that we're going to come back to, because what I want to look at is we have this request and release of interaction points. So I'm going to bring those up. Again, from a point of view of ordering things nicely, which also means that the request is going to go before the release. So the idea is that we'll have specific interaction points, and those interaction points, I want to be able to lock them. So when someone decides that they're going to perform a particular interaction, they lock a particular point. That's part of what they get back from locking things. So what I'm going to keep track of is I'm going to have a dictionary up here. So I'm going to have a dictionary. And this is going to hold our interaction points and just a bool to indicate if they are usable. So this controls our interaction point usability. So we just knew that. And what I will do is when I go and process all of the points here, I'm also going to take that opportunity to mark them as being usable. Just means that it's all sort of set up from the very beginning. Just again, keeps it nice and organized and gets everything in the right state to begin with. So, okay, when we go to request an interaction point, so I'm going to store here our found point, which I'll default to null, and we'll return that. Then what I want to look for is, okay, well, for each, this is going to be var point in interaction points. So if this point, well, actually point, this is, we're actually looping over the interaction point usability. So this is our usability KVP. So if the value is true, that means it's usable, which means found point is equal to the key. And we can just break out straight away. Nothing else extra we need to do. So the other thing I will then do is if we found a point, so found point not equal to null, well, because we're requesting it, I'm going to say interaction point usability, found point is false. So we just lock that point. So now nothing else will be able to use it. Now later on, we could do stuff here with randomizing this or scoring and selecting of the points. But for now, we don't really need that sort of additional logic. So that's good. So what I'll do in the release is our interaction point usability. Just set that back to true. So that's good. So making progress. I'm also going to set up here a protected void update. And in the update, we're just going to do tick time.delta time. Okay, good so far. We've got the ability to do that particular logic. We have our stuff for beginning and abandoning and filtering. So I'm going to move filter to later. Bring that here. That will be one that we do a concrete sort of implementation on. Our tick, we can implement that. It's pretty straightforward because all it needs to do is go through every interaction. And specifically, this should only be our active interactions. And we then just do interaction and we tick that. So that's good. Now, our general logic here, we're starting to sort of get to the particular lifecycle functions. So I'm going to, again, reorganize these a little bit. Tick, I will move up alongside where we actually do the ticking here. I think that makes sense. So that's in the same place. Then I'm going to reorder these so that the began is before abandoned, and we'll move tick up here. So that looks good. Now, in terms of what these ones need to do, well, when an interaction began, I want to go and say, okay, active interactions, and we add, and we just actually pop that in the list. So that's good. So we know that that interaction is currently being performed. When we tick, absolutely nothing that we need to be doing here. But I will make these virtual in case something wanted to override them. So that's good. When we abandon an interaction, well, we're going to remove it like that. This also gets marked as virtual. Now finished corresponds to actually reaching the end of an interaction. So that also needs to remove it. So that's good. So we've got our hooks for knowing, okay, we have begun, we are ticking it, abandon it, finished it. That allows us to do additional logic there if we need. Filtering, pretty straightforward, very similar to what we've already done in the registry. So in this case, our filtered list, that we do interactions, and we do find all. We provide a filter predicate. We again check, okay, if that ended up null, or if it ended up empty, then we'll just return null. If we have a sort method, then what I'm going to do is just go filtered list, sort by that. I'm going to rename that actually, so again, it's consistent with what we've used in other ones. So that's good. And then we just return the filtered list. So, okay. So we've got our filtering of the interactions. We've got our hooks here for our begin and everything like of that. Our tick. So far, so good. The main remaining thing actually is implementing our isUsable. That actually has a reasonable amount of logic to it. And we'll see why. So, okay, if that interaction that we're providing is valid. So if it is valid and if that interaction is mutually exclusive and we have active interactions currently. So in this case, what we know at this point is we're requesting to perform an interaction. The one that we're trying to perform is mutually exclusive, and we have active interactions happening. So mutually exclusive, just in this case, should mean that other things could still perform it. So if an interaction allows multiple performers, for example. So what I'm going to do in this case is if active interactions contains this one, and specifically we'll then invert that. In that case, we return false. So what this would mean is we can't start a new mutually exclusive interaction if other interactions are happening, but we could potentially join it if it allows multiple performers. So that's good. Now, if we just actually have no interactions, so if interactions is null, or if the interactions.count is 0, then we can't do anything. We'll just exit out. So that's a straightforward one. Generally shouldn't happen, but good to check it anyway. What I'm going to do is, okay, check with the interactions. So we'll loop through our active ones. So if the interaction is mutually exclusive, oops, not interactions. So if this one is mutually exclusive and that interaction is not this one that's currently coming in, then we'll return false. So the idea here, again, we're kind of having to test this from two sort of sides. So one is testing if this one coming in is mutually exclusive, then we look to see if it's a case of joining. The other one is if the one that's coming in is not mutually exclusive, but we're already in the middle of one. So in that case, we allow it to just essentially exit out. So it won't try and perform it. Now I want to check, okay, are there any usable points to actually work with? So, okay, usable points, we're going to default that to false, and we'll loop through that. So we have usability AVP, and this is our interaction point usability. So if this point is usable, then we can default that to true, and we can break. And then at the end here, if there are no usable points, we return false. So what we're doing is checking, okay, we've made sure you handled mutually exclusive aspects. What we want to check is, okay, is this something where there are no points for us to actually be able to use? So that looks good. Then, final thing we'll do, by default, we'll return, actually we'll return true here because we've handled if there's no usable points. I'm going to also handle if we have IInTeraction is null, I want to just make sure that any interaction is usable. So we have to have at least something that's usable. It won't be an IInteractive ones. So, okay. I'm going to check, okay, do we have any usable? If we don't get that there are any usable, we'll return false. And all we're checking for here is if interaction is usable. And if it is, then we can set that to true and break. So the usability check here is really the most complicated thing. It is quite complicated. We need to, with our mutually exclusive check here, we need to look at and see, okay, interaction, and we can check, okay, current performer count. If that current performer count is greater than or equal to our max simultaneous performers, then we wouldn't be able to join it. So what we've checked here is, okay, we know that we're trying to join a mutually exclusive interaction. And if we are, but there's actually no space, then we exit out. We're going to do a similar check down here, except this one runs on that interaction. So again, we're checking, can we actually join this? There's a bunch of different things that we're needing to check here. This is really sort of the trickiest and most involved part of this. So it ends up being quite a lot that we're having to do here for this. But that's good. We've got our simple interactable connected up. So that's something we can make use of. Now we have our interaction. So this is going to be a simple interaction. And we're going to have a bunch of similar things that we run into with this. So this is again mono behavior. It's an IInteraction. And we'll initially get rid of the start and everything there. But I will bring over this, just because that makes it easier for setting these up. So this interaction. And then we will implement this interface. So there is quite a bit that we need to set up with this. The actual interaction itself handles quite a lot of logic. So it's going to be quite a bit to get up and running for this. Okay, so now that we've told it to do the default implementation of the interface, there's a lot of stuff that we need to actually get sort of set up here for this. So we're going to do our general sort of changes, but we're also going to do a couple of sort of specific things that we need to do for this. So whether something is mutually exclusive or not, that we're going to do our get and our protected set and default that to false. We'll do similar for our max simultaneous performers. That will get defaulted to 1. Now, current performer count, that's actually something where what we need to do is be keeping track of our current performers, which we're not currently doing that. So what I'm going to do is I need to have some way of tracking that. And the performers have also got specific info for them. So I'm going to set up a class here for performer info. I'm not going to populate anything in it just yet. I just want to define that that class will exist, because then what I can actually set up further down is a dictionary that maps from our performer to our performer info, and that is our current performers. And we will just new that from the beginning. So what that means is current performer count here, it's able to just be current performers dot count. So that's good. Stuff like our owner, that can be our get and protected set. Those are ones that get populated as part of our binding. Same thing with our look targets and our interaction points. So those are things that we need to be able to populate there. Our debug display name, I'm going to make that so that we can override it, but I'm going to populate that from the beginning in awake. So we'll have our debug display name, and that's just going to be our game object name. So, okay, so far so good. Now with this, there's a couple of these that actually should be exposed. So our mutually exclusive, the number of simultaneous performers, those are all things that should be accessible. I also want to have things like our minimum duration, which we haven't sort of specified so far, but I think simple ones, we want to support that. So we'll default that to, I think I'll just default it to 0. And we'll do the same thing for max duration. Now, all of these 4 actually are ones that I want to have exposed. So what I'm going to do, because their properties and currently wouldn't be visible in the inspector, if I do field, serialize field, then that will go and apply that so that they're actually accessible within the inspector, because that applies this attribute to that backing field. So it's really handy. I can populate the performer info now. So a couple of things I'm going to need with this is I want to know, have we actually started? Which that can default to false. I want to keep track of the duration. The reason being is that the duration, if I've got a min and max, that duration is going to vary for each one. So that's good. I want to have our time elapsed. I want to, with this, also keep track of our interaction point that we are using. So that's going to be our interaction point. Actually, I'll just call that linked point. We want to have our callbacks that can be provided for the sort of tick and the completion here. So the reason being is that the point we get those at and the point we need to use them at can be quite separated. So a performer info is a way of sort of encapsulating all of that information. So this kind of pattern where we make use of a little class to encapsulate data for that is really quite handy. So this is our on tick callback function. And then we also have a system action because it doesn't need to return anything. And this is our on completed callback function. So there hasn't been a use case for tracking abandon in that yet, so that's why those don't currently have an entry. So, okay, that's good so far. That's a lot of sort of the key things that we're going to need to keep track of. Now a bunch of these, I'm going to just group them up. Now with this, I want to have it that different interactions can be restricted to different amounts of interaction points. Now, initially, what I am going to do for this is something that later on I will do some custom editor logic to provide a cleaner way of doing this. The reason I'm doing it a simpler, slightly more brute force method to begin with is simply down to the fact that I want to avoid this being a ridiculously long set of tutorials for having this improved interaction system. Stuff like of that is things that I want to have a dedicated amount of time to focus to, because it's actually a reasonable amount of editor logic that we need to set up, and there's already a lot of sort of boilerplate stuff going through with this. So that is a thing I will do later. What I am going to do for now, as a way of actually sort of doing this in a little bit of a simpler sort of setup, is I'm going to have here, and these will just be a serialize field, and I'm going to have a list of game objects, and what this is going to be is our look target game objects, and we'll have a similar one that will be our interaction point game objects. Just makes it possible for us to easily sort of grab the info from those. So it's a little bit more involved than I would like. It's a little bit sort of heavier weight than I would like, but it's going to make things simpler initially and avoids this tutorial becoming excessively long. So when we're in awake, that's when I'm going to populate this info, because I'm just processing these game objects. So I'm not looking at any sort of custom data on them. So it's kind of, it's something where it's safe to do within awake. I wouldn't do any interactions with those particular scripts I'm going to grab, but it's fine to actually just do this basic level of retrieval. That's okay. So that binding side is fine. So if look target game objects is valid, so if it is not equal to null, then what I'm going to do is look targets. Now we'll actually also check that there are entries. So it has to be valid and the count has to be greater than 0. So what I will do in that case is look targets, a new list like that, and we size it based upon that count. Then I loop over my candidate game object in my look target game objects. And then what I'm trying to do here is, okay, our interaction look target, I want to just do a candidate game object, and I want to do a get component of that look target. And what I could actually do is I could set that to null, and I could do this as a try get component. Do a try get component like that. If we were successful, then we add it in. So transfer look targets from game objects. That's good. That brings over all of the look targets. It's largely the same logic for our interaction points. So this is our interaction points. So in this case, we change to interaction point game objects. So we just, everywhere we were doing this, and we end up, what we're getting is interaction point. Put that in each of these. Rename that last one. So it's a little bit involved. Like, it isn't the cleanest of sort of setups there, but it does get us up and running without having to spend a large amount of time setting up the editor logic. So I'm going to move our bind function up here because that's one that we can implement straight away. It's pretty straightforward. Owner is our owner. Very little that we need to do with it. Gathering of the debug data. I'm going to bring that up and we'll populate that too, because it's also one that's pretty straightforward what it's needing to do. So all we're needing to do is we add a text line, and what we add in is our debug display name, and I'm going to put current performer count of our max simultaneous performers. So for now, that's all I'm going to output with it, is just, okay, how many are actually performing this that could perform it? Just kind of useful to have that information there. So, okay, other ones that we need to get set up here. So locking and unlocking the interaction are pretty important ones. And I'm going to do those next. Our begin and abandon, I'm going to actually move those down here so that they are nearer the tick, and I will, again, this is just a minor quibble, but I just want to have the begin be before the abandon. And we'll populate the usability in a moment. So, okay, lock interaction is a pretty important one. So what I'm going to do is initially set our outfound point to null, so that's properly populated. So if this is not usable, then we can't lock the interaction. And what I'm going to do is log out an error. I'm not going to throw an exception in this case, but I want to have an error be logged out. So we're going to say our IInPerformer and our display name. And what it is doing is it's attempting to lock an unusable interaction, and we can output our display name. That just makes it clear of what's sort of happening there on, and we'll put owner and the debug display name. So that's good. That tells us exactly which interaction has failed to be usable. So it makes it nice and clear of the context for everything. So, okay, that's one option that could cause it to fail. The other could be if our current performers contains this performer. So that's also bad. That would mean we're trying to lock the same thing multiple times. So we can actually reuse this message, but we will change the logic here, trying to lock an interaction multiple times. It's good. So, okay, that's a couple of the reasons why it could fail. Okay, so then our next thing is we want to try and get a point. So our owner, we want to request an interaction point. Now that could fail. So if our outFound point is invalid, well, going to do similar logic here. Would not find point for interaction. Would not find a usable point, I think would be more accurate. So that's good. So, okay, if we get to this point, then we know that we're going to succeed, which is great. So what we then do is we work out how long is this actually going to run for? So our duration, our working duration. Well, if min duration is greater than 0 and our max duration is greater than the min, then we can do a random range. Now we have ended up with system included, so I'm going to get rid of that. Fine. The reason it's going to be grumpy is because it automatically dragged in system. A few of these ones are going to be cranky, which is okay. So we're going to be implementing them momentarily. This is why I try to avoid system actually being dragged in, just because it interferes with our random range and then it just makes everything messier. So, okay, so far so good. So we've populated the found point. We're checking here, we're doing a random range of min duration to max. Otherwise, we'll just actually use the min duration. So if we've got an actual range, we use a random roll. Otherwise, we just use whatever's configured as the minimum value. Then I'm going to create the details for that performer. So performer, we call it just entry. Here's a new performer info. Now, in terms of what I want to populate with this, so I don't have those public currently, but I can just do the multi-line and go public like that. So now I can go, okay, well, B has started. That should be false because we haven't started it yet. What I would then say is our duration is the working duration and our time elapsed is 0 and our interaction point, our linked point, is our found point. So that looks good. And I'm just going to actually do this over multiple lines. I think makes it a little bit clearer about what's happening. Good. And then what I'm going to do is we'll say, okay, current performers, and we add that entry in. Could actually do it inline if I wanted as well. Let's do that there. It's actually a little bit cleaner, so I might leave it as that. Could even do the duration in that line as well, but I'll do that separate just for readability. So, okay, that's what we need to do for locking an interaction. Now, for unlocking an interaction, it's actually not too involved. When we go to unlock, well, we're going to default to returning true. Now, the only scenario really where this can actually fail. So if the current performers and we're going to try and get the value. If it fails, then yes, we will return false. And I'm going to use actually, I think the same one here from trying to lock it multiple times. Just saves me writing it all out and also keeps it consistent. To unlock an interaction multiple times, or an interaction it does not have locked. That's the last error there for our system. Removing of those, we just fix those up so that they're not erroring on us. So that's good. Now, when we go and do this, I'm going to tell the owner to release the interaction point, and we get entry linked point. And then from the current performers, I can remove that particular entry. So that's how we go about unlocking an interaction. So, okay, so far, so good. I'm going to implement is usable now because we've got a lot of the stuff already there. So we could say if current performer count is greater than or equal to max simultaneous performers, we return false. Going to return true by default. And we'll double check, okay, if the owner is usable, and specifically if they are not usable for us, then we return false. So that's good. So, okay, so far so good. We can check usability, we can lock an interaction, we can unlock an interaction. Now we have our logic for when we begin an interaction. So initially, we actually need to do this logic here. It's actually the exact same bit of logic we have to do. So attempting to start an interaction, it does not have a lock on. Does not have locked on that, so that's good. So okay, at this point, we know we've got a valid entry. That's important. Now what I would say is, okay, at that point, we're going to do owner.began interaction. We provide the performer, and we are the interaction that's kicked off. I will update the entry to say that it has started to begin with. We need to populate into there our onCompleted callback and our onTick that we have accessible in this function. Gets a little confused with the autocomplete there at times. So we've linked up those. We've run our began interaction. I want to check, okay, is this an instantaneous one? So if performer entry, and our duration is less than or equal to 0, then that means we can finish immediately. So we're checking, is this an instantaneous one? If it is, then what I do is it's going to get one call of the tick logic. So if we have our onTick callback function set, so if that was passed in, then I'm going to invoke that. And we give our indication of, okay, here is the progress essentially towards that. So our duration was 0, and we've finished 100% of that duration. So that's good. Then what I would do is we have our logic for telling the owner that we have finished the interaction. So So that's good. Now there's going to be a bit of cleanup logic that we have to actually do, and we're going to have a few things that need this. So I'm going to actually have a helper function here that is just a complete interaction in performer, and we provide the entry. So that's going to be set up here. So this takes in a performer, and it takes in the performer info. Like that. So that's one that we'll get to implementing momentarily. But this is our initial logic. We go and we tell it that it's actually completed. All of that gets run. So that's good. Then what I'm going to do is return true. Like that. So okay, so far so good. Our completion in terms of what it needs to do. So F in entry has a onCompleted callback function. Then we would run it. So that onCompleted callback function, we go to the invoke, it just needs to provide ourselves. So that's good. When it's done, what we want to do is, okay, if the current performers still contains us. So if it still contains a key for this, then I'm going to do the unlock at this point. So this is kind of one of the changes that I made with this design versus the previous design I was using. So in this scenario, you can handle the unlocking here if you're wanting to, but if you don't handle it, then it forces that cleanup to actually happen, just to make sure that things get properly worked with. So it just makes it a lot cleaner and neater in terms of everything. So, okay, so far that's good. So we can send out the finished notification. We could actually do that on finished sort of setup that we do here. We could do that in our complete interaction. So there would be nothing stopping us doing that. If I was going to do that, what I would say is I would inform the owner once any completion logic there has been done. So, okay, that's good. Now we can implement the tick logic. We'll get to abandon in a moment, but I want to do tick first. So first thing I want to do is for each performer AVP in current performers. So with this, I'm going to grab out the performer. Get the key, and we get our performer info entry, and that's the value. So if this hasn't started, which is possible, so if it hasn't started, then we just skip it. There's nothing to actually do. So we skip if it hasn't started. Otherwise, our entry and our time elapsed gets updated. We figure out what our overall progress is. So our progress is the mathf min, because we want to avoid it going over 1. So it's the minimum of 1, and perform our entry time elapsed divided by duration. So that's good. Again, things are only going to be tickable if they have a valid duration there, so that will work. So, okay, that's good. Now what I want to do is we might have our callback. So if we're trying to abandon this, by default we'll assume we're not, but if our entry has an onTick callback function that is configured, then what I will do is abandon is our entry onTick callback function. Provide in this. Right in this, we provide in the entry and the time elapsed, and we provide the progress value. So if we are choosing to abandon this, then what I will do is say, okay, well, owner, we abandon an interaction. Here was the performer, and here's the interaction that got abandoned. So it's just helpful to make sure it's being properly informed that that's happened. So, okay, we're nearly done with this. Now, what we want to look for here is if we are abandoned, or if the entry's time elapsed is greater than its duration, we are actually finished. So we want to remove it from the list of current performers, but we don't want to do that right now. So I'm going to actually create a list here. And this is our performers to clean up. So that's good. So performers to clean up gets that added into it. So, okay, then we can actually perform that cleanup. Have our performer in performers to clean up. And all we need to do with this is we actually can just remove it by doing this complete interaction. So that gives us the entry there. So then to get the particular one to clean up, we can just look that up. So we'll complete the interactions. So, okay, that largely looks all good. We've implemented most of the things. Our abandon one here, we want to implement the logic for it because it needs to try to actually look up the interaction. So we're going to do a similar bit of logic here. So we'll try to actually logic. So we'll just update this, let it know that we're trying to abandon one that it doesn't have locked, because that would be not good. So we know that it is actually running at this point. Now, what we want to actually then do is, well, our owner, we need to release the interaction point, and we can get that from our entry, and we can remove that from the current performers because it doesn't need to be doing anything. So that looks good. We do need to tell the owner that we abandoned the interaction. So make sure we tell it that this got abandoned. So, okay, we've implemented those bits of logic. Now, there is a bit of sort of similarity there with some of the things that are happening here. And one of the things that we'll notice is, okay, a bit of a difference here between when we're trying to abandon things versus completing them, because complete sends this finished interaction, which would mean that if something gets abandoned, it would send the abandoned interaction, and then it would tell the send through that finished interaction, which is not great. That's probably not really what we want to actually have happen there with that. So what I'm going to do is remove that from there, and I'm going to split this out a little bit. So we're going to check our logic here separately. If it's actually finished, then we'll send the notification directly, and then we will add it in to the ones to be cleaned up. So that's better. That gives us some cleaner logic there with this. So we're sending through, when it's instantaneous, we send through the begin, but we haven't sent through the actual finished one. So I'm going to make sure that we do that. So we're going to do our owner, and we actually have the ticked one as well that we should be sending through. So our IInPerformer and this, and immediately we're going to then send the finished one as well. So okay, if it begins, that gets sent through. We send through tick and we send through finished. We've got the callbacks that happen here. We are running our complete interaction, which complete interaction will handle running that on completed callback, and it handles the unlocking. So our begin looks good. Our abandon, we do our cleanup logic. We tell the owner that we've abandoned it. So this is for an external abandoning. In our tick, we are properly telling it when we've abandoned, and we're telling it when we've finished, but we're not telling it when we're actually just ticked it. So I am going to also put here ticked interaction, and we have our performer. Yes, so we just want to make sure that we're not missing any of these particular ones. It's just really easy to actually do. So we've been making sure that we've got all of these properly hooked up. The one callback that we missed is here for F. We have an onBegan callback function. Then we want to make sure we run that, because we could fail to run it. If we don't have performers, we shouldn't actually run it because we haven't begun it. So, okay, if we go and check, we don't have any errors showing up. So that's good. Now, in terms of with setting up more bits for this, I don't want to add in any more bits in this particular tutorial, just because it is really, really long already in terms of with the code. This is the majority of the code. It is quite a lot to be actually going through. The other sections are a lot more straightforward. This was just a lot of setup stuff that we needed to get up and running for it. So what I'm going to then do, just as a bit of an indicator of how these would actually work, if I take a look at something like our microwave, how the setup for this would look is what I would do is I would add in a interactable. So if we look for interact, this is our simple interactable. Now I'm going to, under the microwave, create a couple of empty sort of objects. So this one is going to be our look targets. I'm going to have another one that is going to be our interaction points. And then a final one that is, oops, not under that. Final one that is going to be our interactions. Pan around to the microwave so we can see where everything is. So, okay, our look targets, I'm going to create a single look target for it. So for our look targets, if we take a look at what we've already got for that, that'll be our common ones. Just want to make sure we do have, yep, our look target simple. So we add look target simple. Might actually end up renaming that to have interaction more properly in it. In terms of interaction points, I only want a single one. Interaction point here, that gets interact, and that is an oriented point. Just to make it easy to actually spot it, I'm going to put a cube attached to it, and I'm just going to relocate it like that and flip it 180 so its forwards direction is pointing at the particular object. So that's good. We've got our interaction point there. Then our interactions, we create an empty one. So we might have heat food. And this gets a simple interaction. We will say that it's mutually exclusive and only one thing can perform it. And heating food might take between 3 and 5 seconds. We only have a single look target, and we only have a single interaction point. But then that interaction, I can just duplicate it, and we might have a make hot drink, and that might take between 2 and 4. But it can use the same look targets. They don't need to change at all with that. So it's a lot easier for setting these up. And I'm going to apply all for now to the prefab. I'm not going to remove the particular old logic first. Actually, no, I will remove that old logic because we don't need it. So apply that again. So it's a lot simpler in terms of setup. We just actually have that one script there, and then things like our targets, we largely can just duplicate them. We could have dedicated targets per interaction that it can be using. Some cases we don't need that, but we can support that. And we have our interaction points are built in, and the orientation of them actually matters, because one of the other changes that's happened sort of in the background with this is the navigation has more support for handling the actual orientation for the destinations. So that's been quite a lot. There's been a lot to get set up with this. This is quite a huge system. And this is one of the things, setting it up this way with having interfaces and everything does make it more complicated. It does mean our initial setup work is significantly higher. As we've seen, we've spent nearly a couple of hours getting this implemented, and it's not being used yet by the behaviors. It takes a lot longer for setting these things up, but once it's set up, using it is quicker, extending it is quicker and is easier. So we're spending time now to make things easier later on. And this is one of the big things that you see on projects where there's experienced folks working on it. The initial version of something might take longer, but then afterwards, it's much easier to use, it's much easier to extend. And that's what we will find with this, that it actually simplifies a lot of our downstream logic, and it means modifying the behaviors and everything like that is a lot easier. So that's the payoff further on. So if you've stuck with this, thank you. I do apologize for how lengthy it's been, but the next sections should be much shorter and hopefully a bit more digestible. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, there are 3 links in the description below. The first link is to the code as it was at the start of this project. The second link is to the code as it is at the end of this tutorial, and the third link is to the completed package. So you've got all of those available. You can use those in any of your own projects. If you have any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time.